Now what do we do, or what can we do to avoid such problems? One is the seasoning of wood. Okay. So what is seasoning? Seasoning is the process of controlled drying, not just drying. Okay. Controlled drying to remove sap and reduce the moisture without causing cracks and distortions. So it's like we know that it will, whether you dry it or not, it will happen, right, over a period of time. So it's better that we do it in a controlled way before we start making the structure with wood. So that is what we call as seasoning, or you are preparing that wood to be used for the structure, so that once the structure is built, then there is no further deformations. So all the deformations which can happen because of shrinkage, we are forcing that to happen before the structure is built, and that process is what we call seasoning. And what is it? It is nothing but removal of sap and moisture from the wood, but not just heavy drying, but not just drying, but making sure that during that process there is no cracking or distortions happening on the wood. So we go for a slow process in general. Okay. Now the rate of evaporation will depend on the type of wood which we use, the shape and thickness of the wood, the volume, mass to the surface to volume ratio, etc., and the condition under which the wood will eventually be used also. Okay. Now natural seasoning is one way, and another way is artificial or accelerated seasoning. Okay. So with natural seasoning, you can actually get about 80 to 90% moisture can be removed from wood. Okay. But it takes time. Now in the case of artificial or accelerated seasoning, you can remove even up to 95% of the moisture can be removed. So you have only left moisture content is only 5%. In the natural seasoning case, you can have about 10 to 20% of moisture content. Okay. So artificial or accelerated seasoning can remove more moisture than natural seasoning, but there are disadvantages also for that, because you have to see the other properties, like whether it will be warping, etc., etc., and too much drying is also probably not good. It might affect the other properties of the wood. Now so typically the quality is inferior with artificial seasoning. Anyway, considering the demand of processed wood, etc., nowadays it's mostly it is artificial seasoning becomes necessary for us to meet the demand of the market. Now what is natural seasoning? It's essentially natural or air seasoning. We just leave the wood under sun and but not direct exposure to sun. You can see here the photograph on the right side, where the wood is stacked and then a sheet is kept on top, so that it is not getting the direct sunlight and also no direct moisture attack. Okay. Now free circulation of air is another thing, and then faster if immersed in water before drying to remove sap. Okay. That I will show a picture on the next slide about that, and then takes about 2 to 6 months or more for proper seasoning, sometime even years it will take, depending on the type of wood. Okay. Now it says hardwood takes more time than the softwood. Now let us look at seasoning of wood through artificial or accelerated way. Essentially here what we do is we immerse wood in water and then do air drying. Okay. So you can see the picture on the left side, where you can see logs floating on the water body. Okay. And that's kind of immersion, or it gets exposed to water, or sometimes even river water. People use you tie logs into the river, or sometimes let the wood float in the river itself during the transportation, and all that helps or part of the seasoning process, and then eventually they dry it. So what happens is the strength also reduces due to the excessive loss of organic material. That's something which also a concern, but eventually you get a better wood which will have more resistance against shrinkage, etc. Okay. This is another example of an artificial or accelerated seasoning. You can see here a kiln, a picture of that, and different elements of a modern day kiln where timber is seasoned. See, these kind of setups are necessary because the demand for wood is so high in our today's construction. So, you cannot really avoid artificial seasoning. You cannot really depend only on natural seasoning. So, you can pause here and look at different elements of this setup where they ensure maximum air circulation, because the whole idea of doing this is remove moisture. Okay, so you increase the temperature so that water tries to evaporate, and make sure that there is a good circulation of air, so that the humid air inside the room can be taken out, so that more and more moisture from the wood is pulled out or is drawn out, and then eventually you have a dried or seasoned wood. Okay. This is another example, just some schematic to show you how things are. So you need to have a supply of heat energy, which could be either due to electrical sources or due to fuel or even due to solar cells. All these are being used, and then at the same time you need to have a very good supply, a very good circulation of air, so that the humid air inside the chamber is taken out and more moisture from the wood is removed, or it is being dried in a controlled manner. Now, let us look at the desired mechanical properties. Okay. Now, this is an example of a beam. Okay. You can see the example of a beam here, simply supported beam. You can see one support here, another support here, and a load is applied from the top. Okay. Now, look at in this beam element, which portion of the beam element is experiencing tension, which portion is experiencing compression, and also which portion is experiencing shear. Okay. So, you can see here, when you have a simply supported beam like this is going to bend like this. This is a typical bending, right. Now, because of this, so let me draw it again. This might bend something like this, something like this. That means the top portion is under compression. At the center of the span, the top portion is under compression, and at the center of the span, the bottom portion is under tension. Now, there is another interesting feature here. You can see here there are fibers are in the horizontal line, right. So, when this bending happens, what will happen is these fibers will try to slide. Okay. And that is why we have horizontal shear force also. Okay, because they are trying to slide each other. So, these are the different things, different type of stresses which are generated when we apply load onto wood elements, structural members. Now, the failure modes, compression failure, we already saw that in the previous slide. There is a compression mode failure possible, tension failure possible, and also shear failure possible. Okay. So, let us look at the compression failure mode. The picture on the top right are examples of the test specimens, and the picture on the sketch on the bottom indicate different type of failure. The case A, this is crushing. Okay. You can see here there is a crushing of the fibers happening. Okay. So, you can try to correlate this with the on picture photograph on the top right also. Now, the second one is wedge. You can see a wedge shape forming here. Okay. And then it is going into this. So, that kind of failure. Now, third one is shear failure. You can see like a shear action here, and here also this much is under shear, this is under another shear plane. Okay. So, these three things, and then you have a splitting action. Here the angle, see in the case of shear, the angle is almost about 45 degree, no, 45 degree, right. But in case of splitting, you will see that the angle is not 45, but it is more parallel to the grain, or along, this is the angle we are talking about. Okay, this is less than 45 degree. Okay, so this angle is a very small. So the angle between the failure plane and the grain direction is very small or acute angle. Now, crushing, in the case E, you have crushing and splitting. So it is not that if you take a timber, only these first 4 will be happening. You can have a combination also. So this, you look at here, it is crushing, this is crushing, and then you have splitting in this direction here, and here you have splitting, and then maybe a little bit of shear failure also here. Okay. So this you have to really look at and try to analyze. And then you have case F, which is brooming or end rolling. You can see here, depending on what type of load was applied at the top, and then probably there is a local failure or local crushing happening at the top surface itself. Okay. So these are different ways by which the wood can fail when a compressive load is applied parallel to the grain. Okay, so you can see all these arrows on the top and bottom, they indicate like compressive force is applied in the direction parallel to the grain direction. Now, comparison of compression in various directions. Previous slide we looked at compression when it is applied parallel to the grain direction. Okay, that is axial compression, case A. Imagine the straw which you have in your hand, you can see the photograph. Now, if I apply the load from top and bottom or ends of the straw, that is the axial compression, case A. Okay. What will happen is, if one straw tries to buckle or something, then the other straw will kind of give that lateral support, so the whole system works perfect. Now, second one is tangential compression, okay, where you are trying to this is the other view. Okay. So in the case A, it is side view. Okay. Case B, it is top view. This case C is also top view. Okay. I am saying top view, side view and top view of the bunch of straw in the hand. Okay. So now you can imagine how things are. Now, in the second case, case B, when I say tangential compression, or even in case C, it is also radial compression. It is like you are squeezing in. Okay. So what will happen is these straw, the walls of the straw will collapse. They will collapse, so the load carrying capacity is much smaller in the lateral direction than in the axial direction. Okay. So you can easily imagine this thing. Now, effect of moisture content on the compressive strength. So you can see here again the similar picture which I showed earlier. At about 100% till about 20 to 30%, the load compressive strength. Earlier we looked at the shrinkage property, but this is more on the compressive strength. You can see that there is no much change in the compressive strength of the timber when the until the moisture content is about fiber saturation point or FSP. Until that point there is not much change, 20 to 30%. But further drying, it leads to increase in the compressive stress, because your cell walls are all very tightly packed, the air content inside the timber or wood is very less, so it can take really high strength. Okay. Now, tension failure mode, you can see here this arrow is going or showing tensile load and parallel to the grain direction. So, how do they fail? They fail in splintering tension, first option. Then that is this splinter, you can see the splinters are formed, and the second one, combined tension. So, here it is tension failure, here it is tension failure, and the center region is shear failure. Okay. So, shear, tension, tension. Now, the third case you can see it's a pure kind of shear failure. This is all shear failure. Okay. Then fourth is tension, pure tension. So, pure tension, pure shear, splintering and a combination of tension and shear. So, these are the 4 different ways by which wood can fail when you apply a tension load in the direction parallel to the fibers. Now, if the tension is applied perpendicular to the fibers, this one is applied perpendicular to the fiber, then you can see how it is. So, you can see the rings here, late wood and early wood, you can see there, right. So, this is late wood and this is the lighter color is the early wood, you can see that there. Now, what happens when you apply the tensile load in this direction? So, it's like you have the bunch of straws and you are pulling your hand in opposite direction like that. So, tensile failure of early wood can happen. You can see here the early wood is failing, that white region is actually failing. This is the white region which is failing, and again on this case B you can see shear failure happening, again that is in the white region, that means the early wood is failing. Okay. And then in the third case you have again a failure which is pulled in the other direction, because you can look at the ring direction is also changing there. So, they have a pure tension failure. Both across cutting through both early wood and the late wood. Okay. So, these two you can think these are actually probably like tangential direction, these are the radial direction, and this one is case of a tangential direction. The tension force is applied in the tangential direction. In the first two, A and B, the tension force is applied in the radial direction. Now, look at how these tensile, tension and compressive strengths of the same timber is in different directions. So, very widely we know that it is they vary widely because of the anisotropic nature of wood and also the presence of moisture, other defects, etc. And it's a natural product. That's the most important thing, because it is natural, you don't really have the control on how the fiber should be, where should be the defects or knots, etc., etc. You don't have much control. Now, tensile strength is greater, this is very important, is greater than compressive strength. Okay. Now, you can see here the tensile strength, it's much more than the compressive strength. And also when you look at the direction, parallel to grain, it's about 20 times more than the perpendicular to the grain. So, this is tension, and you can look at the compressive force also. This is longitudinal direction, and then this is tangential and lateral, tangential and radial, which is lateral we can say. Okay. So, this longitudinal direction, the strength is much higher than the other direction. That is the key message from this. Okay. So, parallel to the grain, both the tension and compression, it can take more than in the other direction. Now, flexural strength, you can see the same image which I showed you earlier, where you see a simply supported beam. Now, let us look at this A, B, C, D, E, F 6 drawings on the right side, how they are the failure mechanism. As I said, look at this is the tension region, this is the compression region, this is the horizontal shear region. Okay. So, these regions we look. First, let us look at the tension region, and then you can see in the case A, you have a failure like this, which is simple tension. So, you can say this failure, this fiber here are failing in tension, and then you have cross grain failure. So, you can see here across that late wood, early wood region, there is a shear, not shear, it just gets pulled apart, and that is why we call it cross grain tension, not the failure along the length of the fiber, but the individual fibers get separated. Okay, that is what is happening in the case 2. Now, third case is again splintering, and fourth case is pure tension, Fifth case is there is a compression failure at the top of the element, and then you have a horizontal shear failure near the support, where you have a tendency of sliding of the fibers. Okay. So, these are the ways by which the timber or wood would fail. Now, next time when you go see structures, you should really look for if there are failures, what type of failure it is and all that you can look for. Now, generally, like in any structure, joints are very, very important. Okay. So, here also in case of wood structures, joints and connections have significant influence on the on their overall performance. So, look at the picture on the top left, you can very clearly see that this joint has failed. Okay. So, it has broken at the joint, and the second picture on the top right, you can see that there is a failure here, and this joint is actually failing. Okay. So, there is a movement at the joint. Okay. And you also, if you look very carefully, this point here is actually some moisture attack is there, probably because this joint, the plate is holding and giving more moisture, and then that location near the joint is actually getting exposed to more moisture and then getting weakened. Now, in the bottom left image, you can see again it is a joint which is not designed well. If you tighten the screws too much, then it causes a shear action in this plane. Okay. Okay. Imagine the direction of the screw. As you push screw further to the left, there is a shear failure along the periphery of the screw. Okay. So, here also you can see a small crack happening. So, you should not over tighten all that. So, you have to see what is this wood capable of, what is the strength, what is its strength. So, this positioning, spacing, etc. The spacing means how much space should be there between the screws, etc., where the screw should be placed. All these are very, very important, otherwise the system as a whole will not work. Okay. So, here also you can see there is a failure at the joint because the connections are not properly designed, and here also you can see there is a failure here. Okay. This joint is not properly made. So, all these are very, very important. It is not only the size of the wooden element, how the multiple elements are put together or joined together, or we call it connection. So, that how that connection behaves is also very important when we think about wood structures. Also, there are lot of bacterial, fungal or insect, termite attack, etc. So, we will not go more deep into this, but this is also something which you have to worry about while talking about wood structures, and you have to provide proper protection against all this before you start using the structure. So, in house construction, if you look at any construction going on, you will see that they will apply some coating at the back side. For example, the wooden door frame, they will apply some coating at the back side of the door frame, which comes in contact with the concrete or whatever the material we use, so that there is no attack of these biological elements, or the insect, termite, fungus, bacteria, etc. cannot attack the wood directly. So, some kind of protection is very much essential, otherwise they will degrade, and then you will have to replace the wood. So, one way by which these things can be protected is by providing some treatment, chemical treatment. Okay. So, one thing which is widely adopted is, I already mentioned about applying a coating, but this is another chemical treatment given to the entire wood as a bulk itself. So, it is done by penetrating some liquid into the wood. Okay, by pressurizing them at high temperature, heat and moisture. So, you impress or impregnate some chemical into the wood structure. So, structural members need to be fabricated as much as possible before treatment in order to expose untreated wood by cutting, drilling holes, etc. So, what essentially we do is we cut the wood and then pass them through some chemical, or let them have some chemical treatment, and then only we will use for structural real structural application, so that the damage after the structure is made is very less. So, you can see here very contrasting behavior, one on the left side in this photograph and one on the right side in this photograph. The one on the right side is a treated wood, same dimension. One on the left side also had same dimension, but after some time, because of various damage mechanisms. So, the treatment, chemical treatment definitely helps in enhancing the resistance against biological attack. And main thing is keep the wood dry and keep it above from ground if possible. These are the ways by which you can protect timber from getting damaged. Now, let us look at couple of wood products. Okay, plywood, widely used in many construction, we use plywood. Now, thin sheets are also used for this, so that is why we call it plies. Okay. Then grains are arranged in right angle in different layers. Okay. So, you can see here, this is a cross section, you can see layer 1, there is an outer layer, just some sheet, and then layer 1, 2, 3, 4, 5. So, you can see here there are 5 layers, and then there is a small cosmetic layer on the. So, the longer lines which I drawn are just the cosmetic layer, then others are the main layers of the plywood. So, always most of the time you will see that plywood, they will have this odd number layer, that is mainly because of making sure that it has same direction for the look also. Anyway, the point is the anisotropic nature of wood is it's changed when you make a plywood. In the case of a plywood, you will have similar properties in both the direction, whether you take it in this direction or in this direction, you will have similar properties, because the grains in this in individual layers are arranged in 90 degrees, okay, in the opposite direction. So, the properties in both directions becomes more or less similar. Now, how is it made? So, you can see the picture on the bottom left, where you have a log, or a stem of a tree, etc. It's big, and then we cut about 2 millimeter thick veneers is cut or peeled off from the log. Okay. In the next slide, I will show a picture. So, before going there, so this is one ply, okay, and then this is the cutting tool or knife, and then you kind of peel off, you let this thing rotate, this log is rotated, and then you take the layers. Actually, you can see it on here. It's a real a photo from a factory, where you can see this from the log. So, the log is rotated, and then these veneers or layers of wood is peeled off and then used for making plywood. So, you can giant lathe machine here, which cuts the wood and then gets these layers of thin sheets of veneer comes out, and then they are put together to form the plywood. Now, other type of product which are recently coming into the market are, because in the wood industry there is lot of this waste being generated because of the cutting action, etc. So, what they do is, instead of throwing them as waste, we try to use them to produce more products which can be useful. Okay. So, the waste is of different size and shape. So, for example, you can have sawdust, very fine powder. Then you can also have chips, slightly larger sawdust, slightly larger pieces which could be in millimeter size, and then chips and strands where it could be several millimeters, maybe even a centimeter in the lateral direction, and then longer pieces. You can see here the 3 pictures on the right side, which kind of shows you difference between a sawdust, a chip, and a chip and strands. Now, then these materials are put together, glued and compressed to form sheets, okay, or similar to plywood. They are compressed. So, these are all waste material, you have to remember that, okay. scrap material. They are put together, mixed together and processed and then glued together, okay, typically using a resin, and then compressed to form sheets which can be used as either particle board or chipboard or oriented strand board. So, based on the type of raw material used, these names are evolved. Okay. So, the photographs on the bottom also you can see very clearly, and these are widely used today for furniture making. Many furniture today comes with compressed wood. That is a typical name which people call in the market, compressed wood. So, they are not the natural wood, but they are artificial and made by using waste of wood industry itself. Okay. And it is not equivalent to plywood. Plywood is a slightly different. There are, in the case of a plywood, you put layers of veneer and you make the plywood. Here it is, compressed wood is a slightly different. Now, there is some danger associated or the deterioration mechanism. You can see even in your furniture at home, if it is a compressed wood, you will notice that the corners etc., where there is a possibility, let us say you dropped a little bit of coffee or something, then moisture gets in and it starts swelling. Okay. So, you can see here on the top left a typical which you might have seen, where moisture, so this is one major problem with this kind of products is that they are not much, you have to ask for moisture resistance, otherwise the typical products which you get, they have a lot of air void inside. So, there is a tendency for them to absorb the moisture, and once it absorbs, the wood will swell. Why it will swell? You can see the moisture picture on the right side, the black image which is a microstructure image. You can see the cavities are all filled with moisture and then it swells. Okay. So, all these small cavities which you see in this black micrograph, you can see that cavities can get filled with moisture and then it will swell. So, how much the swelling can be? You can see here the picture on the bottom left which kind of indicates how much the swelling can be. So, you can actually have significant damage on these kind of products if you do not protect them from moisture attack. So, you have to really, when you use compressed wood or these artificial products, make sure that it is well protected against moisture. Now, another product which is used for structural applications even are glue laminated timbers. It is essentially a deep beam made out of timber. Okay. So, you can see on the left side a balanced glue lamp, on the right side is an unbalanced glue lamp. Essentially, like plywood, we have different layers. Here also you have different layers, one layer, second layer, third layer, and a symmetry is followed here on the top. This top 3 and bottom 3 is a mirror image if you look carefully on the balanced glue lamp. Okay. On the unbalanced glue lamp, it is not necessarily a mirror image, but it's okay. It's not necessarily a mirror image, but you still have good properties. So, point for you to note here is that if you want a deep beam, let us say you want a beam which is like 1 feet deep and let us say half a feet wide, and you do not have to really cut a large tree for that. What you can do is, you can get smaller tree stems or wooden pieces and glue them together to make the large piece. That is the whole idea. Okay. Instead of cutting large trees, we can get small wooden pieces and then glue and glue them together. Like if you remember in vehicles and all that, the axle, there are these plates like this, no? If you look in train or anywhere, so this is essentially laminated wooden element or wooden beam. Okay. So, these are examples of this glue lamp. You can see here multiple applications where here you have multiple layers of wood. Okay. So, for example, here these are multiple layers. It is not just one timber. These are all multiple layers or laminates of wood to form a beam structure. These are all beam columns and beams you can see on the left structure. Now, other wide application of wood is nowadays to use as floor joist for construction. Even formwork is lot of formwork, because these are all something which you have to handle at construction site, and if you have a lighter element, it's always preferable for the workers to use. So this is I think with this I will stop the lecture today. So we kind of covered the various uses of the wood and what are the different properties and different types of wood we covered. We looked at the seasoning, and we looked at how the shrinkage properties, we looked at the structure, physical and chemical structure of wood, and then we also talked about different mechanical properties and different products which are available, and the concerns, the moisture attack and other things, how we should be careful while using such products. I think with that I will close this lecture on wood. Thank you.